Well, first of all, Dr. Raff, congratulations on winning one of our Positive Droplet Awards, but also thank you for contributing to the advancement of droplet digital PCR and digital PCR in general. It's because of researchers such as yourself that our technology has just been growing at an extremely rapid rate and is getting more and more adoption. Well, I guess my first question would be, obviously you've started using digital PCR prior to COVID, even though you did use it quite a bit for COVID work. So what sort of gave you insights, or what made you decide that digital PCR was probably a good application or a good tool for the applications that you were trying to?
We found like the multiplexing capability of the ddPCR was quite also something that interested us, because when most assays that we were using for qPCR were detecting a single target, so we had to multiplex in another channel to essentially detect two targets in different channels. But we were interested in seeing how the copies of one target can fluctuate within a single channel. So by using the higher order multiplex approach for ddPCR, essentially in the same channel, using the same dye, we could ideally see what is happening between two genes per se. Let me say that. Yeah. So it had several advantages that made us lean towards ddPCR.
It did definitely, yes, definitely.
Yeah.
You definitely had the sensitivity at the low end and the accuracy at the low end, and also the multiplexing capability. You've published quite a few articles, and you are using many of the strategies for advanced multiplexing, not just using two channels and two targets, but you've done triplex, tetraplex, using amplitude multiplexing, and even using, I believe, evergreen. I believe there was an evergreen that you did, which was also a duplex.
Yeah. We found out like the field for multiplexing, especially using a two-color ddPCR system, is okay. We found like there are techniques out there. They are already been established, but we think like this can even be pushed further. One thing that is also exciting about ddPCR is we still don't know the full limits that it can do. Every day, people are trying to explore new ways of multiplexing, new ways of detecting more targets, which is essentially a very beneficial thing. The reason why we took multiplexing by digital PCR, especially the higher order multiplexing, as opposed to qPCR, is because I like qPCR. If one target is abundant than the other, well, the other one will not compete as the one that is more abundant than it. But with digital PCR, the partitioning power helps it to essentially equals the playing field for all the two. But if you have more than one target that you want to detect, it essentially equals the playing ground.
So, of course, with the arrival of SARS-CoV-19 a few years back, that in essence forced you to pivot from the research you were doing to, all hands on COVID and trying to tackle that problem we have. Can you tell us a little bit about that pivoting?
Yeah, when COVID hit, our lab is based in Wuhan, so we were the first people to experience COVID. So it was a challenging fact for many labs. We couldn't understand. It was a new pathogen, so diagnosing this pathogen was of utmost importance, especially for us in Wuhan during that time. So what happened now is we couldn't continue with our normal research because we have a priority pathogen at our hands. So we need to find solutions on how to tackle this. So what happened during the early stages of the pandemic, and many people can agree, there were no reference standards because this is sort of a new pathogen that is coming out. So we had no reference standard, especially to validate our assays. We developed our own in-house assays to detect COVID-19 based on qPCR. So we didn't have reference standards to validate these assays, how they can perform analytical performance to detect the samples that were coming in. So one thing that we found that was very great for us is like we had a digital PCR, ddPCR system in our lab. So this we quickly used it to generate reference standards based on both patient samples and we did cell culture samples. So this reference standard that we had quantified with, we knew the copies of different genes, so we could use them essentially to validate not only our assays but during that time, new assays were being produced, also the other assays. So we could know the performance of these assays, and we could select which ones are good to be used in essentially in qPCR for detection. So during that time, I think ddPCR really helped us a lot.
Are there any people you would like to shout out or bring to
Yeah.
light
Okay.
for?
First of all, I'd like to thank my professor, Professor Hong Ping-wei. He has been a great mentor and a role model to me. He's supported me in many ways and helped me to kind of explore the boundaries for digital PCR. I also like to thank my fellow lab mates, my fellow students. They also challenged me to think broader and better. And we essentially, if not through their efforts, we couldn't find some of the solutions that we are coming up with now to diagnose different infectious diseases out there. And lastly, I also like to thank my institute. It has been the Wuhan Institute of Virology has been very cooperative in helping us realize our dreams in terms of digital PCR, and help us in every possible way to support our applications. I also thanked other fellow researchers out there who have done research in terms of ddPCR. Most of our work are just maybe advancements of their work, or we borrow a few ideas from here and there from them. I think it's quite interesting. I also like to thank Bio-Rad especially for awarding me this Positive Droplet Award for respiratory tract pathogens. And I will promise in my end, maybe we'll keep on furthering our research and pushing the limits of digital PCR. Thank you so much.